The topic is understanding Kubernetes distribution, kOps, that is Kubernetes operation, DNS, k8s.local versus actual production domain, and understanding Route 53 and its use with respect to domains. A Kubernetes distribution is a prepackaged version of the upstream Kubernetes source code, bundled with the necessary configuration, installation tools, and integrated third-party components like networking, plugins, and container runtimes to make it operational. While Kubernetes is open source, the vanilla code requires significant manual effort to secure and scale. Distributions like Amazon, EKS, Google, GKE, OpenShift, that is for Red Hat, or kOps provide a curated, tested, and supported environment to simplify lifecycle management. So a Kubernetes distribution simply is a prepackaged version of the upstream Kubernetes source code, which means Kubernetes in itself is open source platform. So distributors or cloud providers, that is Amazon, Google, or Red Hat, has used that Kubernetes open source and added a few features here and there and created their own version of Kubernetes, that is EKS for Amazon, GKE for Google, and OpenShift for Red Hat, etc. Though the core components of Kubernetes are present, they have added a few plugins, CLI tools, etc. The main point here is that they have added accountability and responsibility management, which simply means that if you face any issues regarding your EKS for Amazon or Google, etc., for these providers, they would be providing you with the assistance to solve the issue. However, if you use the Kubernetes in itself without these providers, you would have to deal it yourself, or they would also solve the issues, but it would not be as reliable as Amazon, Google, or whatever the other platforms offer, because they would also charge you some amount for these services. Now let's understand the role of kOps or Kubernetes operations. kOps is an open source tool primarily used to provision, upgrade, and manage highly available production grade Kubernetes clusters on cloud providers, specifically AWS. It is often referred to as the kubectl for clusters. kOps is same as Kubernetes, that is open source tool which is used for provision, upgrade, and to manage highly available production grade Kubernetes clusters on cloud providers, especially AWS. So kOps is an open source tool which is primarily used for provision, upgrade, and to manage highly available clusters of the Kubernetes on cloud providers, specifically for the AWS. And one more thing to remember is, although we are discussing kOps, but there are other options as well that is offered by other providers. For example, OpenShift for Red Hat, etc. But we are discussing kOps, which is most common and most widely used. Now, importance and purpose of kOps or Kubernetes operations. Infrastructure as a code. kOps generates the underlying infrastructure, EC2 instances, ASGs, VPCs, IAM roles required to run the cluster. Automated lifecycle. It handles complex tasks like rolling updates to nodes, operating system patching, and scaling the control plane. Self-healing. If a master or worker node fails, kOps ensures the underlying auto-scaling group ASG replaces it to maintain the desired state. So kOps helps in infrastructure as code and to automate the lifecycle and for self-healing, which simply is management of our production grade Kubernetes clusters on cloud providers. Now, S3 as the state store. When managing hundreds of clusters, kOps or Kubernetes operations require a single source of truth for configuration. It uses a S3 bucket as its state store. Why it is used for centralized management. Every cluster's desired configuration, instance types, networking, security groups is stored as YAML in S3. Consistency at scale. An administrator can manage hundreds of clusters from any machine by simply pointing the kOps state store environment variable to that bucket. Disaster recovery. Because the state is external to the cluster, you can reconstruct an entire environment from the S3 metadata if the control plane is lost. S3 bucket with respect to kOps is to store our configuration information or configuration data. For example, instance types, networking, security groups, which is stored as YAML in the S3 bucket. Administrator can manage hundreds of clusters from any machine by simply pointing kOps state store environment variable to that bucket. It is also used in disaster recovery. If the control plane and its data is lost, we can reconstruct the entire environment from using S3 metadata. So it acts as a backup of our data and information with respect to clusters in Kubernetes. DNS strategy .k8s.local versus actual domains. kOps uses DNS for cluster discovery. How nodes find the API server. The choice between a gossip-based domain and a real domain dictates how the cluster is reachable. Feature discovery. k8s.local uses gossip protocol, that is, nodes talk to find each other. Actual domain uses standard DNS lookups via a provider like Route 53. Complexity. k8s.local complexity is 0. No registrar or DNS configuration needed. Whereas in actual domain, it is high. It requires a registered domain and a hosted zone. Reliability. k8s.local is prone to latency or scaling issues in very large clusters, whereas actual domain is rock solid, highly scalable and standard. Accessibility. k8s.local is best for local development or simple private VPCs, whereas actual domain is essential for production and multi-account setups. For production and multi-account setups and production-ready environment, or for production, we use actual domain, and for local development or testing phase, that is apart from the production environment, we use actual domain or production.example.com. Whereas if we are testing or in the local development stage, we can use k8s.local to configure and debug information and to debug our cluster. And for production, we use actual domain, and for local development and for testing our application or any stage apart from production, we can use k8s.local to debug or polish our cluster information and its availability, scaling, etc. After we confirm these information while performing test, while preparing our clusters in k8s.local, once we are sure that it is scalable and it is really great for production, then we can switch to actual domain and provide the production ready clusters. Now, the necessity of Route 53. If we choose to use an actual domain instead of k8s.local, kOps requires a DNS provider to create necessary records. Records for API, SRV records for etcd. So we discussed that for local development or any development other than production grade, we can use .local, k8s.local for testing and local development apart from production. But when we confirm and when we are sure that the cluster is ready for production, we use the actual domain. So here comes a part when we use actual domain. In AWS, the standard or most widely used choice is Route 53. In AWS system, Route 53 is the standard choice. During kOps create cluster process, kOps will query the Route 53 hosted zone for your domain, automatically create the public or private entries for your load balancers, configure the internal cluster components to use these endpoints for secure communication. TLS or SSL certificates are often mapped to these DNS names. So for production grade, we use Route 53 as a DNS provider. So what Route 50 does is it queries the Route 53 hosted zone for our domain. It creates public private entries for our load balancers. It configures internal cluster components for secure communication. These are often mapped to these DNS names via TLS or SSL certificates. So that is it for the video today. I hope the topic was simple and insightful. Thanks so much. Have a great day. Bye.